Okay, our next step is to place the signal head symbols onto the track diagram that we've been previously using, our simple oval with the two side tracks. In order to do that, we have to first define the signals that we're going to place on the layout. So we come to the Panel Pro menu, go to the Tools menu, come down to Tables, across to Signals and Signal Heads, and click on that. That will bring up this Signal Heads table, and you'll see that there's nothing in there because we haven't defined any of the signals that we are going to use. So we'll start with defining each of the positions that we want, which will be A1, A2 on this end at the throat of the turnout. We'll want B on the opposite end of the main line, and C, which would be at the end of the diverging portion of the turnout. So we'll define these lights, and we do that by coming down to the Add button down here at the bottom of this table, and we click on that, and it will give us this window, which is located in the upper corner here. I'll move it down so that we can work with it a little bit better. Actually, I'll put it right here in the middle. And what we are now going to do is to define the 4 signal heads that we want to install on our layout. You'll notice that here at the top is a description of the type of signal we're going to add, and it says double output. That's not what we want, so we're going to drop down the box, and what we're dealing with is the SE74 aspect. This is the symbol for the signals that were dealt with by Digitrax SE74 controller previously. So far, JMRI has not yet been able to get all of the details for the SE74 to put into this drop-down box, but the signals for the SE8C will work just exactly the same. So we're going to select SE8C, and now you see that that's the type of signal that we are adding. Our next step is to add a username, and in this case our username is going to be the name of the turnout, which in this case is 325, and then it will be turnout 325 A1 and A2. So we'll just type in TO 325 A1 for our first light, and we now have to give it the controlling numbers. And so there are 2 of those. I'm not quite sure why JMRI refers to that as turnout 1 and turnout 2, other than it has something to do with the number 1 and number 2 controlling number. If you recall now, our number for A1 is 331 and 332 from our diagram from the table that we prepared earlier. So here we're going to create a new number, and it's going to be 331. And down for the second number is entered down here as 332. Once we have accomplished that, we can hit the Create button, and you'll see that up here it has created a line showing that signal head. It defines a system name that basically shows you what 2 numbers, switch numbers, are associated with that switch head. Here's the name we assigned to it, the turnout 325 A1. Okay, now we'll go ahead and we'll also come back and we're going to create another light, only this one will be 325 A2. So we just change that to 325 A2. we again have to create numbers for that. And if we go to our sheet, once again, the number for A2 is 329 and 330. So we'll change this to 329, and we'll make this one 330. Oops, 330. Okay, and we'll create that. So now we can see that we have A1 and A2 defined using the turnout numbers that we have associated with the SE74. Those are the four switch numbers that you see up here. Those are the four switch numbers that correspond on our data sheet to the A1 and A2 lights. Okay, but we still need two more. We need the B and the C. So we're going to create another light. This one will be TO325B. Whoops, capital B. And from our table, again, 325B is controlled by the numbers 335 and 336. So our first number here, we have to create new, is 335. And then we have to create the second one, which is 336. Okay, and those are, then we can go ahead and create that. Now we see that we have 325B with those controlling numbers. And then finally, we have to do the C. So we'll change that to a C. We come down, and the controlling numbers for the C, the switch numbers that control C, are 333 and 334. So we'll enter 333, create another one, 334, and create that light. And again, now we see we have A1, A2, B, and C, and here are the controlling numbers from each of those that we got off of our spreadsheet that we've kept track of. If you don't remember exactly how these numbers came about, you can go back and review the previous videos where we introduced that spreadsheet and why we developed those particular numbers. So we're done with this box because we don't need to create any more lights right now. We might do some more in a couple of minutes when I show you some other aspects of this whole thing. So we can close this box and get rid of it. Now we don't even need this table any longer, so I'm going to close that for the time being, because basically what we're going to deal with now is we're going to concentrate on the panel and putting the lights on that panel. And so I'm going to center this a little bit better and maybe increase so that you can see a little bit better as to what we're going to do next. Now the first thing that we want to do is to place those signal lights onto our diagram. This is how we connect the JMRI to the SE74 controlling those signal lights. So we're going to go up here and we're going to place a signal head icon. So we'll click in that little button there, and then there's a drop down box over here, and it will show you the four lights that we just installed or defined in our table. The first one we're going to place is the A1 light, so we'll click on that. Now in order to place it, we want to place it over here, and in order to do that, we move our mouse button to where we want to place it. We hold down the shift key and left click, and you see we get a symbol here that represents the turnout 325A1 light, and that's where it's located for now. You notice that it's facing the wrong way, which is typical of all these. When you place these signals onto the diagram, they're going to always be in this position. Well, we want it to face the other way around. So we'll right click on that, and we get this menu here, And one of those is to rotate. Well, we're going to rotate it 180 degrees. We click OK, and you say, wait, nothing happened. Yep, that's typical of JMRI. Bring your mouse down over it and notice that now that light symbol is facing the opposite direction. So that's the A1. If you put your mouse over it, you'll see that it actually gives you the name that we have assigned to it. Turnout 325 A1. Okay, now the next one we want to place is the A2 light. So we'll come over to this drop-down box again and select A2. Again, we come down to where we want to place it, and we hold the Shift key down and left click. Again, the symbol comes up facing the wrong direction, so we'll right click on it, rotate it 180 degrees, okay, put the mouse over it, there it is. Now you can move that around using the right mouse button. You click on it and you can make it look just like a real symbol. We actually can make these change color just by clicking on them, because at this point in time they really are not hooked up to anything. They're just lights that are on our diagram. We're going to make them mean something in just a short period of time. But those two lights are now the A1, A2 lights for turnout number 325. There. You got to be careful where you touch it, because the symbols are, it's a little large symbol here, and if you get in the wrong spot, you'll get the wrong label placed to it. Okay, now the next one we want to place is the B light. That light, if you recall, is on the main line opposite the throat of the turnout. So we'll go up here once again to the drop-down box and choose 325B. We come down with the Shift key and left click, and we get a symbol. Now this time the symbol is facing exactly the way we want. I'm going to move it up just a little bit so that it's a little further away from the track. And that now is our 325B light. We also want to now place the C signal light down here on the diverging track approaching this direction. So we'll go back up to the drop-down box, check 325C. Again, with the Shift key down, we'll left click where we want the light to be. That's pretty close. I'm going to move it up just a little bit. And notice it also is in the right direction. Well, this one, if we click on it, we can make it red because it really can't, the turnout isn't set. And we can make this one green just for the heck of it, so that it makes it look correct. Although they're really not doing anything yet because we haven't associated them with any other functioning. And if you change this turnout, they won't do anything. They're not going to change colors because we have not set up the logic for these two lights. However, if we were looking at our lights, the little display that I had given you, as we click these colors, the colors on those signal heads will change as well. So we are actually physically controlling the lights that we have hooked up to the SE74. So at this point, this whole diagram is set up and actually changing the signal lights that we've installed. And the signal heads would change color, and it's just a little too hard to show you all of that here in this video view. But trust me, they are changing color. I'm looking at them. Okay, now, the thing that we want to do next is to set up the logic as to how this works. And the way that we do that is we click on each individual light. So we're going to right-click on the A1 light, and we get this menu. And if you look down here, it says Edit Logic. So we'll click on Edit Logic. And we get a box that I will bring down here where you can see it. And there's a whole bunch of things that we have to fix. First of all, it's got the signal head label up here at the top, 325A1. But it says what type of a signal head is it? Is it on a single block, like between two blocks? Nope, not this one. Is it on the main leg of a turnout? Yes, the A1 light represents the main leg of this turnout, number 325. So we'll check that. And that changes some of the choices we get down here. The other choices, of course, are diverging leg turnout, facing point turnout. And I won't get into facing point turnout right now. That's a little bit beyond the scope of what we're doing today. But the diverging leg is another one that we will show. And we'll also deal with single block. Okay, now we've defined this A1 as being on the main leg of the turnout. That gives us a chance to say, okay, what sensors do we want this light to protect? In other words, if there is a train in a block, do we want this light to show red or yellow, or what do we want it to do? And this is how we set it all up, is in this logic table that we're doing right here. So the first block that we want to protect is we want this light to be red if there's a train occupying block 1325, which all it is that the block includes the turnout itself. We defined it that way. If you go back to previous videos, I explain why we do that. So we'll go to the drop-down box over here, and we come down, and there it is right there. Sensor 1325 is what operates that block 1325. So we want the light to protect that block. But because we don't have a light at the beginning of this block, that light should also protect block 101. So we'll add that over here, and we'll say we want it to protect sensor 101, which is hooked up to block 101. So we want it to protect that particular block. And I'll show you how all this works in just a minute, but let's complete filling in the table. Now this says that the light will be red when a particular turnout state is thrown. Well, which one would that be? Well, it would be turnout 325. So we come over and we choose turnout 325. And now what we're saying is that if this turnout is thrown, that light, A1, should be red because that represents the main line, not the diverging line. Well, for now, that's all we're going to do. I'm going to later come back and show you what this protect signal means, and we'll deal with that in a little bit. Okay, so now that we've set this up, we come down and we click on the button that says Apply, and all of the things appear to be operating the way they're supposed to, so we can close this logic block. And that completes the entire setup for the A1 light. For now, what it will do is it will monitor the position of this turnout, so that if we click the turnout and change it to the thrown position, that light will go red. Notice that nothing else changed because we haven't set any of the other logic up, but just turning this back and forth will change that light, the A1 light. We can also go to our menu here, go to Tools, Tables, come over to Sensors, and load the sensors. And the sensor for block 101 is sensor 101. If we were to click on that and make it active, what you will see is this block will turn red. Okay, so that means that block is occupied. And now you see that the signal A1 is also red, because in our logic we said that we wanted it to monitor these two blocks, and if either one was occupied, or both of them, it gives it a red light over here, so that the trains cannot go past this signal because this block is occupied. So that is what this signal right here is telling us. It'll stay red if we change the turnout, because now there's two reasons. One, the turnout is thrown, which would give us a red signal here, and that block is occupied. But if we were to go back to this table and make that block inactive, it won't change this to green because the signal is thrown. Now, all of these sensors are hooked up to your block detection hardware, which in my case is a BDL168. Okay, so I'm going to close that, or just move it out of the way for now. I said I was going to move it out of the way, but it went big. Okay, so now we've set up this one A1 light. The next thing we want to do is set up the logic for the A2 light. So we right-click on it, come down to Edit Logic. It opens up our logic definition screen, and we do the same thing that we did before. Notice we have now turnout 325A2 light. It's not on a single block. It's not on the main leg of a turnout. It is now on the diverging leg of the turnout. So that changes the choices that we have down here below. Well, what sensors do we want to protect? Well, we still want to protect the block detection for block 1325. So we'll still put that one in there, because if it's occupied, you can't go by this light no matter what. So we'll go down and select sensor 1325. That's one of the blocks that we want to protect. The other block that we want to protect is this one, 201, which is where the train is coming into. Again, we don't have a light at the beginning of the block facing this way. We don't have a light in there. This one is actually, this light here should be on the other side of the track. It should be over here on the right-hand side. My bad. Okay, we don't have a light going this way on the right side of the track. So in that block here, we want to protect also block 201. So we'll select sensor 201. The light A2 should be red when the turnout number 325 is closed. That then is if it is in the closed or mainline position, the A2 light over here is red. So for now, we've gotten everything set up in this. We can come down and apply and close that definition box. So now we have 2 of the 4 lights logic set up, and if we click turning this turnout, these lights you see will switch to reflect the appropriate symbol, red for the main line if it's thrown, green because it's going to the diverging line. When it's on the main line, you get green over red. Okay, we still got 2 more to do, so we'll do those. Let's pick the B first. Again, you right-click it to get the menu. Come down and do the logic. I'll bring the box down where you can see it. This is on the main leg of the turnout, not the diverging leg. So we have to choose main leg. And here we have a couple of things to look at. Again, this light should protect the sensor for block 1325, which is where the turnout is located. So we'll come down, choose 1325 as one of the sensors it's protecting. The next one, again, we don't have a light for entering this block 106 over here. So this light will protect both of them. So we need to enter 106 over here as another sensor to be protected. That way, if either of these blocks has a train in it, this light will be red. Also, we want the light to be red if this turnout is in state thrown. So we need to choose turnout number 325, so that if it is thrown, then this light up here will be red. Again, we have completed all of the definitions, so we come down and apply and close. Now, if you click on this turnout, you'll notice that several things happen. All three of these lights will change. Notice that the mainline lights are red because you can't go straight ahead either way. Okay? We still have one more to do. And by now you probably got it all figured out. Right click, edit logic. I'll pull this down where we can see it. Again, this light, the C light, is on the diverging leg of the turnout. So we've defined it, and that gives us a difference in choices down here. Again, we want to protect this block. So the first block that we want to protect is 1325. And also, just like we did with the B light, we want the C light to stop a train here if there's a train in block 106. So we will choose 106 as the second protected sensor. We want this light to be red if this turnout is in the closed position as it is now. So that turnout is 325. We choose that. And we have completed all the definitions for this particular light. We apply, close, and now we're all set up. As we turn this turnout, notice that all four of those lights change position. Okay? So now, just to test a few things, let's make this block 106 active. So I'll come up here to 106 and I'll make it active. That turns it red on the diagram, and notice that now this light on the main line, even though the turnout is set correctly, that light is red, indicating that you cannot go past here because it's not safe. It would be the same indication if you turn the turnout. Notice that the C light is also red because you can't go by this light because that block is occupied. Now let's suppose we make this turnout occupied, so that, for example, maybe a train has come off of this siding and is pulling out here, and there might still be some cars in the turnout. So we'll go over and we'll make that block 1325 active. Okay, now we've made that turnout block active, showing that the last of the train is still in there. But notice that that did not change either of these red lights, because both of those red lights were monitoring whether or not this block was active. So making this block active or inactive doesn't change anything. I can make it inactive again and those lights will stay the same. The one thing that did change is that the A2 light over here goes from green to red, because if you were coming in this direction, this train can go now, but with this block active, it's saying, oh, no, you can't. But that would be because this train is coming in this direction. There would be some kind of a conflict here that you had another train sitting on there, but the light is correct. But that's all that does there. And likewise, if you make this a closed turnout for the main line, and then you then make that block active again, it doesn't do anything for the main line. Both that will still show that it's a red light going in this direction. Again, you're getting the green light going this way, so that if you didn't know which way the train was going, if the train was coming this way, the train could go straight ahead. There's nothing to stop it. So that's the logic that we have set up for these 4 lights so far. Okay, I'm going to return all of the sensors back to inactive, and we're going to set up a slightly different scenario. In this case, I want to show you how you could use the sensors of one of the SE74 set of 4 lights to give block detection between 2 blocks. Let's suppose, as you see here, we have block 101 and block 102. We want to monitor, we want to have a light right here at the block boundary to show whether it's safe to go into block 102 from 101. As an example, we can set up 2 of the signal heads from 1/2 of a SE74, just like we've got 4 lights over here. You can take 2 of them and use them, for example, to monitor the 2 directions right here. You could then take the other 2 and use them to monitor the 2 directions down here. And I'll show you exactly how to do that. In this case, we won't actually set up everything, but we will add some lights, and I'll show you a couple of ways to do this. This is kind of an interesting thing called a virtual light, and in this case we're going to come up and switch to the signal head table again, and we're going to add some lights, some signals. And in this case, I have to bring this little box down where you can see it. In this case, not a double output. What we're going to do is to add a virtual signal down here. So we'll change what we're numbering this. We'll call it virtual signal. And it will not be associated with a real-time signal on the layout. It doesn't have, it's not hooked up to the SE74 at this time. If you were going to hook it up to the SE74, you could then go back to using this SE8C aspect, but we're going to keep it as virtual. And we're going to call this block, wait a minute, let's do it this way, block 101 to 102. That is the light that is monitoring the boundary between block 101 going into block 102. We're going to name it that. We'll create it. We have to give it a system name up here, so we'll call it LH1 and create. So now we have a system name of LH1 and a username of block 101, 102. I'm going to create a couple of more. We'll create system name 2, and we'll just reverse this right here. We'll call it 102 into 101. And we'll create that. And you notice that it then appears in the signal head table over here. I'm going to do also, I'm going to create lights that we can put down here for the same reason. So I'm going to call this LH3, and this will be block 201 into 202. So we'll just change this block 201 to 202, create. And we have another one over here. And a fourth one. And we'll call this 202 into 201. And we'll create that. So now we have, I should have named these different. I should have stuck with my I'm going to rename them and put the BK in front of them just to make it all the same. And I'll rename this one also BK, just to keep everything standard. Okay, now we've got usernames over here that are pretty descriptive of what they are. So we're all done defining signal heads. We can close that table, and for now we don't need the sensor table either, so I'll close it. And we don't need this box to define anymore. What we're now going to do is put those 4 signal heads on here. So we've got signal head icon indicated up here, but we have to choose which one we want to put on. So let's take this one, block 101 to 102, and let's put it on the diagram, and we'll hold the shift key down and click, and notice that it's in the wrong direction again. So we'll have to rotate that 180 degrees. And you don't need 1800 degrees. Okay, and now it's in the right direction. And we're going to put another block signal over here. That will be block 102 into 101. Shift key. It goes on the right side of the track. So there it is. I'll move it up just a little bit. And it's in the right direction already. Now we'll put the 2 down here on this siding. So this will be block 201 into 202. And it would go right here. Shift key, left click. We'll move it where we want it, and we have to reverse or rotate the direction. So we'll rotate it 180 degrees. There it is. And then one final one going this way will be 202 into 201. We've chosen it up on this signal head icon, and shift, left click, there's the symbol, and it is set up in the right position. These 2 should probably be lined up, as these 2 should be lined up. And you can do all of that pretty easily that way. Okay, now what do? Well, we have to define all 4 of these. So let's start up here with this one, 101 going into 102. All right, so we want to edit the logic. Here's the edit logic box again. And what do we want it to do? Well, this light should monitor if this block is occupied. And so what we want to do is, first of all, we want to say that signal is on a single block. In other words, it's protecting a block boundary. There's no turnouts included with it. So here we're going to come in and say we want to protect the sensor for block 102. So that's sensor 102 right there. There's no other signal involved. I'll get into that in a minute, because you could have signals down here around this light, and that would further enhance the meaning of all of these lights. But for now, let's just leave this as protecting that block. That's all we really need to do. So we'll apply it and close it. And that light is currently showing green because this block is unoccupied. Now, we don't have a physical light installed, but we do have a light that's here that we can reference. And what I'm going to do is I'm going to show you why you might go back and change this particular light right here, light A1. And let's pull it up and say edit the logic again. And I'll bring it down like this. Let's see if I can get it where it'll make sense. Okay. One of the things that we didn't fill out before is this line called protects signal. So right now, this signal head is only telling you, is the turnout set in the proper direction, and is block 101 available? But what if block 102 is got a train sitting in it? Should that be something that we want to have some indication on our signal? We don't need this right now. What I need is to pull up the menu. Get it up here. We need the sensors table. Okay. Now with the sensors table, let's suppose we make block 102 active. Okay, so there's a train sitting in there. This light says you can't go in there. But back here, shouldn't you get some kind of a warning that's saying, hey, you might have to stop up ahead? So that's where we come in with this light, the A1 light, and we say the A1 light should protect this signal. So we want it to protect the signal block 101 to 102. That's that light right there, that signal light. And if we put that in here, and then we apply the logic to it and close it, notice what we get. We now get a yellow light here, and yes, indeedy, it's yellow on our mock-up below. Because what it's saying is you're cleared to go into the next block, but be prepared to stop at the next light. And that's exactly what we've got right here. We've got a stop signal here. The train can come into this block, but it must stop here because there's something going on beyond this light. You don't necessarily know what it is, but you know it's stop. And this light gives you the warning that you're going to have to stop. Now, if you turn this signal over here, this turnout to the siding, you won't get a yellow light because that's not involved here. In fact, you could come around this parked train and go out. That could be an alternate route. But for the time being, anytime you get this straight, this signal light, A1, is monitoring this block, this turnout, and also the light for this block, saying if that light is red, I'm going to give you warning that you're going to have to stop up ahead. If we take the activity off of this track here, then this will go back to green. So now we can set up the other one monitoring the block going this way. Again, we do it by right-clicking, coming down to Edit Logic. We get our box down here where we can see it. Again, it is on a single block. Yeah, I can't put it in the right place. I guess I'll put it over here. Okay, the block that we want this light to protect is block 101. So we'll choose block 101. We also would like it to protect this signal right here, so that if this signal is anything other than, if it's a red signal, for example, we would like to know about that. So protecting that is the B light for turnout 325. We choose that here, protecting that signal, and we are done setting up the terms for this particular light up here. So we apply it. Well, notice that it's green right now. Okay, we can close this because we're done with that. So the main line is all clear. But suppose this turnout has been changed to the siding. Now, notice what you get. This light goes red. Well, we knew that. And this light goes to yellow because it's saying you can enter the next block, but be prepared to stop. That is then monitoring or protecting that signal. If we go back to the straight through main line, everything is green. So we've now set up a protection and used all of the possibilities in our logic system to monitor a multitude of situations that could occur. Finally, we can do the same thing with these two lights down here. Let's pick this one right here, edit, bring it down where you can see it. This light would want to monitor block 201. And this light, which is the C light, which is 325C, and now that's monitoring everything there. If we apply it, close, notice that this is yellow now because you're going to have to stop in the next block. The train is cleared to pass that light, go into block 201, but be prepared to stop. If we turn this turnout, notice that you get a green light all the way through. Now we have one final light to set up. Edit. Here's our logic. We want this to monitor the block 202. And at the moment, we have no lights on this turnout down here, so there's nothing we can enter here to protect. So that will be the sum total of our application. So we apply it and close it. But there's one more thing that we could do. This A2 light back here, we would want it to say you might be prepared to stop if this is a red light. So that if this block 202 is occupied or active and this light is red, wouldn't we want this A2 light to be yellow to say, hey, you might have to stop? Well, that's what we're going to have to change in the logic. And we come down to Edit Logic. We get the logic block. And this is where we put in this light should protect that signal right there. And that signal is block 201 into 202. So we'll choose that as one it wants to protect. And if we apply it, you'll see this light go to yellow, because it is now saying you're going to have to stop. You're cleared through the turnout into this block, but you're going to have to stop down there. If this block then becomes clear, this will go back to green, saying that you're good to go on this entire route. So that's how we set up the logic. And all the time we were changing these lights, the lights on our little display down here were also changing. And now that you understand how to put these in, I think you can begin to see how you can change the logic depending on what you want the lights to display. So we have our whole system installed and completed, and this is the end of the explanation for the SE74. If you have questions, put them down below and I'll be glad to try to answer. Thanks for watching.